Hello, this is the meaning of the derivative presentation by Divyavrata Mukhopadhyay, period 2, Mr. Farrar. Our first step is to find the definition of the derivative. On Google, we find that the mathematical definition of the derivative is an expression representing the change of a function with respect to an independent variable. In addition to the common definition found on the internet, the book Calculus Early Transcendentals describes the derivatives and rates of change in the following terms. The problem of finding the tangent line to a curve and the problem of finding the velocity of an object both involve finding the same type of limit. This special type of limit is called a derivative, and we will see that it can be interpreted as a rate of change in any of the sciences or engineering. First, we'll find how you get the limit definition of the derivative. Okay, it is defined as f derivative of x is equal to limit delta x to 0. Let's go down here, and with f of x plus delta x minus f of x all over delta x. Okay, let's move on. Here we have a graph going through P and Q at x and x plus delta x. The slope of the secant line here is f of x plus delta x minus f of x all over delta x. Okay? To get the tangent line, we need to move at Q and P to get closer together in order to get the tangent line at delta at x. Okay? So we set delta x to 0, therefore getting limit of x to delta x to 0 is f of x plus delta x minus f of x is over delta x is equal to f derivative of x, which is the slope of the tangent line. We can use this to find the derivative of any function, but for now we'll just start out with something easy. We'll find the derivative of f of x equals 2x. Okay, so we have x plus delta x times 2 minus 2x, because f of x is equal to 2x, all over delta x. So we have 2x plus 2 delta x minus 2x all over delta x. So we have 2 delta x all over delta x, and it just cancels out, and we have f derivative of x is equal to 2. Moving on. A simple way to say the meaning of the derivative is rate of change. When you have rate of change, you have a regular function. Often it's a position function described as s of t, and then you have a velocity function, otherwise known as rate of change, of the position function, which would be v of t, t being time, and then the rate of change in velocity is acceleration. So you have a of t. Okay, that is the second derivative. This is because, well, it's the second derivative. Moving on. Here we have a problem that uses related rates. No, rates of change, sorry. So we have a sprinter whose position is given by the function s of t is equal to 4x cubed plus 3x squared plus 2x. Okay, then we have and the problem is to find his velocity and acceleration functions and find his velocity and acceleration after 3 seconds. So we have velocity of time is equal to 12x squared plus 6x plus 2, and then we have a of t is equal to 24x plus 6, and these are all equal to f second derivative of x and f derivative of x. Okay, this is a universal formula to find velocity and acceleration functions given the position function. So when we have v of 3, it is equal to 12 times 9 plus 18 plus 2, which we get 108 plus 18 plus 2, 108 plus 20. We have 128 meters per second. Okay, and then we have acceleration at t equal at 3, and we get 72 plus 6 equals 78 m over s. To conclude this lesson, I'll leave you with the message that the meaning of the derivative is constant, and that is that it's always the rate of change of that function. However, in different situations, the meaning of the derivative can change. Thank you.